Alright, so do you guys remember what did we do 2 weeks ago? Exactly 2 weeks ago. Samriddhi, Sahib, Pranit, any idea? No? Okay. I know this gets a little tricky with a break, but it's okay. That's part of my job. I'll help you guys recollect whatever we did. I will start with a picture because pictures speak 1,000 words. This is angle A and this is angle B. We dropped after taking 1 unit length, we dropped a perpendicular, this became a right angle triangle, and from this point we dropped another perpendicular, this is another right angle triangle, and we learned how to derive these formulas for angle addition for sine and cosine. So if I have two angles A and B, sine of A plus B equals sine of A cos B plus cos of A sine B. This is the formula that we derived. And same way we derived the second formula using the same picture, which was cos of A plus B equals cos of A cos of B minus sine of A sine of B. Does it ring the bell for you guys? Yeah. And then we use this concept or this derivation that we did to further. Hi Vishal.
Hi sir.
So Vishal, before you joined, I was bothering everybody to help them recall what did we do in the class 2 weeks ago. And I was just helping everybody recollect that we learned about how do we derive this formula for angle addition for sine and cosine. Sine of A plus B equals sine of A cos B plus cos of A sine B, and cos of A plus B equals cos of A cos of B minus sine of A sine of B. And then we went to the next step where we said, okay, fine, sine of A plus B is fine. How about sine of A minus B? And then we derived this equals something which I don't remember myself, but I will still do it. It is sine of A cos of B. I don't know whether it's plus or minus. Cos of A sine of B. And that is where we came to this unit circle concept to say sine of A minus B is nothing but sine of A plus minus B. So if I'm talking about sine of B versus sine of minus B, what do I mean by that is, when I'm talking about sine of B, I'm measuring the angle in the anti-clockwise direction. When I'm talking about minus B, I'm measuring the angle in clockwise direction. So this angle is minus B, this angle is plus B. So far you guys with me, right? Samriddhi, Sahid, Vishal, Pranit, everybody? Yeah. Samriddhi, you okay with that? Okay. Sahid and Vishal, no questions, right? I know it's been 2 weeks since we talked about this, but I'm just trying to get us back on track and come back to where we had left it. Yeah. So here we were trying to find out what is sine of A minus B. Sine of A plus B equals sine of A cos of B plus cos of A sine of B. What is exactly sine of A minus B? And that is where we said, okay, fine. We don't have to do all this juggling that we did. We can use what we have learned to derive the subsequent stuff. So sine of A minus B is nothing but sine of A plus minus B. And we were trying to wrap our head around what does sine of, see, when we plug this thing into this formula, we will come to sine of A cos of minus B plus cos of A times sine of minus B. So we are trying to understand what is the difference between sine of B and sine of minus B. So B is the angle which is made in the clockwise, anti-clockwise direction. Minus B, when we talk about the angle made in the clockwise direction. And here, when you look at these 2 points in the unit circle context, you will see that sine of every point will have the coordinates like cos of B, comma sine of B. And here, since this angle is minus B, the coordinates of this point will be cos of minus B, comma sine of minus B, based on unit circle concepts. Are you with me so far? Vishal, Sahib, Samriti, everybody okay, right? So again, you don't have to say yes if you have slightest of the doubt in your mind. So here, what is cos of B? Cos of B or cos of minus B is the x coordinate. Be it plus B or minus B, my x coordinate value that doesn't change. Both are positive. So I can happily replace cos of B with a cos of minus B or vice versa. But in case of sine of B and sine of minus B, see here this point, when it is positive B, this is positive value. Y-axis is having y coordinate is a positive value. When I am talking about minus B, my y coordinate, which is sine of minus B, is a negative value. So both are same, mirror image of each other, but this is positive, this is negative. So we can say sine of B is equal to minus of sine of minus B. So we'll just plug in that information in this formula and we can replace it. Yeah. Same thing we can do with cos of A minus B also. Cos of A minus B equals cos of A plus minus B in the bracket. And then you deal with this. So it becomes cos of A, cos of minus B minus sine of A, sine of minus B. And you know that sine of minus B is negative of sine B. Cos of B and cos of minus B are the same. So that helps us derive this formula also. So I will now here, based on whatever drama and circus I was doing, what you see is, if you relate this concept to the unit circle concept, sine of B is equal to sine of minus B, and cos of B and cos of minus B are no different from each other. They are the same. Yeah. So now if I am talking about sine of A minus B, I am essentially talking about sine of A plus minus B, which will be equal to, I have two angles, A and minus B are by two angles. I'll plug it into this formula. It becomes sine of A times cos of minus B plus cos of A times sine of minus B. Sine of A, cos of minus B and cos of B are same, so I'll simply replace each other. Sine of A times cos of B plus cos of A times sine of minus B is negative of sine of B. So I'll say minus sine of B. So this will change the sign here. So this becomes sine of A cos of B, my plus into minus becomes a minus cos of A sine of B. So sine of A plus B was, yes Vishal.
A and B are angle measures, right?
A and B are angle measures, yes.
Yeah.
So they're not the same, they are still different, right?
Yeah.
So basically we derived this formula using this picture, and I'm not going to redo that because that will not be efficient. You guys can watch the video one more time if you have any doubt, but this is what we derived using this diagram. So sine of A plus B, cos of A plus B we derived, and we are just trying to use this information to derive the value for sine of A minus B. And that is when we related that to the unit circle concept. So okay, fine. What is the difference between sine of B and sine of minus B? Negative. What is the difference between cos of B and cos of minus B? They are the same. And we are just plugging in that thing in this equation, and we got that sine of A plus B is this, sine of A minus B will be sine of A cos B minus cos of A sine B. So between A plus B and A minus B of sine, everything remains the same, just the positive sign gets replaced with the negative sign. Make sense? Samriddhi, am I speaking too fast there? Sahit? Okay. So see, Samriddhi said, I asked Samriddhi, am I speaking too fast, beta? She said yes. Does that mean so? So see, I am applying different tricks and techniques to hear everybody's voice. Okay, I don't want to hear you guys because that makes me more confident. Okay, please don't treat me like a math bot, math AI bot. Okay, I'm your math teacher. Okay, all right. So same thing we can do with cos of A minus B also. We'll just replace B with a minus B. So it will be cos of A plus minus B in bracket, and you can use the same understanding to derive that. I'm not going there. Is that okay? Now, these two things we get. Now, again, I think we talked about this in the last class. The point is, why we are even putting that effort to learn all this nonsensical stuff. We know SOHCAHTOA, we know unit circle, we know complementary angle concepts. Why is this needed? Because in your world, meaning for this generation, I don't know whether you guys are Gen Alpha, Gen Z, I don't know exactly. My kids keep talking about it, I keep forgetting about it. Because I'm from a different Zen, right? So, here, in your generation, for you guys, you have the luxury of having a calculator in exams. We never had that. And calculator is nothing but just a tool which uses the human concepts to do the calculation in a much faster way. Sahil, do you agree? So calculator is just a tool. It's just an enabler, okay? Just for doing some mundane calculations for which we don't want to waste our precious time. But the concepts don't change. Now, if you guys remember this table, let me put this table in front of you guys. And again, this one also we have derived in the previous classes, which I'm not wanting to derive now. I will just assume that we have learned and we remember this. If any day you guys feel that we forgot and we are not able to relate to it, I will redo this whole exercise one more time. I'm deriving the value for sine, cos and tan for these commonly used angles. Sine 0 is 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 1. Cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0. And sine over cos is your 10. Now, I was not trying to impress you guys by showing that, see, I remember all the numbers. No. I have just memorized this part, okay, and that too by doing a lot of math during my childhood days and doing the same thing during your childhood days also, right? I'm getting to practice problems quite a lot, as good as you guys. I can appear for SAT exam any given day. Now here, when we have these values, now what is the significance of this thing? Tomorrow somebody says find out sine of 105 degrees. Sine of 105 degrees, you don't really have to scratch your head to get this value. You will say, okay, sine of 105 degree. Do I have some commonly known angles which I can use? Okay, sine of 105 will be sine of 60 plus 45. Now look at this table. You know the value. So this will transpire into sine of A, sine of 60 degree times cos of 45 degree plus cos of 60 degree times sine of 45 degree. Applying this formula. And you can plug in these values. You have sine and cos, all these values here. You can just plug this in. Yeah? So you don't essentially need a calculator. If this formula gets or becomes part of your, what do you call, weaponry, right? That's what you call it. So if it becomes a part of your, all the weapons that you have in your armory, you will just use this. Imagine this. Now this is one example. Now if I say, if I know sine of 30 degree, okay, is 1 by 2. Somebody says, find out the value of sine 15 degree. Now, sine 15 degree. How do I find it? Sine 30 I know, sine 50 I don't know. But can I say sine of 15 degree is sine 45 degree minus 30 degree? And then we'll apply the formula, which will be sine of 45 degree times cos of 30 degree minus cos of 45 degree times sine of 30 degree. Yeah. So this gives you a runway where you can play with things and a lot of things that you can derive by yourself. Tomorrow somebody says, okay, find out the value of cos of 75 degree. In this table, you don't see the cos of 75 anywhere. You can add 40 plus 45 plus 30 to get cos of 45, or you can find out sine of 15 like the way you have found and use the concept of complementary angle where sine of theta is equal to cos of 90 degree minus theta. If you found 15 degree, sine of 15 degree will be equal to cos of 90 degree minus 15 degree, which is cos 75 degree. So these are the opportunities to kind of leverage the knowledge that we have built for solving different types of problems. Am I just super excited without a reason, or I'm resonating with you guys as well? Vishal, Sahit, Samriddhi. Okay, but kids, just make sure that you guys don't always use the emojis for responding to me. Okay, sometimes saying yes makes me very happy. Okay, I'm not asking for a lot. I just love talking to you guys. Okay, so don't stay muted and use emojis only. That makes me I would not say emotionally weak, but technically a little disconnected from you guys. Okay, so try using your natural voice to respond to my questions. Alright, so this is fine. Now let's look at it. Let's generalize this also. Tomorrow if I say, what will be the value of cos of 2 theta? Same thing. Cos of 2 theta will be equal to cos of theta plus theta. My A is 1 theta and B is another theta. Plug that in here. You get it. If somebody says, find out cos of 3 theta. Same thing, cos of 3 theta will be equal to cos of theta plus 2 theta. This is your A, this is your B. You will find out value of cos of 2 theta and basically you will break this down as cos of theta times cos of 2 theta minus sine of theta times sine of 2 theta. And find out the value of cos of 2 theta from this equation, plug it in here. Is that it?
Hi, sorry.
It's okay, but I was missing you so much. No, I'm just kidding. Okay, no, so it's okay. I know you have a class that gets over by 7 and then you need another 10-15 minutes to settle down. So that's the reason. Just try to work it out so that you are able to join on time. If that doesn't work out at all, I'm okay to move this class by 5-10 minutes to make it a little comfortable for you, okay? Is that okay?
No, it's okay. I don't want to change the time for everybody just to like that.
Okay. Alright, so basically, so far what we have done is, we just talked about the angle addition trig identities that we learned about in the previous class. Sine of A plus B, sine of A minus B, cos of A plus B, cos of A minus B. And we were just trying to see, or we were trying to convince ourselves with respect to how does it actually help us to deal with things. Okay? Now, sine and cos we have talked about. How about tan of A plus B? Or when I'm adding two angles of tan, what that would be? How would we derive that? If somebody says tan of A plus B, how much that would be? Now nobody has the option of giving me the thumbs up. Now tell me, what will that be? Direct, Vishal, Pranay, Samriddhi, Sahit. Again, I'm not trying to bother you guys. I'm just trying to engage a little bit more.
Tan
What will this be?
means that you're finding the tangent of the sum of A and B.
Yeah. But what will that be? How will I approach? How will I start? I need a
You
jump
sum A
start.
and B first.
I'm sorry, bro?
You find the sum of A and B first.
No, I'm trying to derive that as a generic rule, like what we derived in the previous class for sine of A plus B.
Yeah, I don't understand this, sorry.
No, so, yes, Pradeep, give me some clue. Say it louder. I know you are thinking the right direction, but I want to hear it loud.
Sine of A divided by cos of A plus sine of B divided by cos of A.
Cos of?
E, sorry.
See, now you will see why I was insisting on you guys saying something. Okay? Now, see, I will say that this is totally wrong. Not to prove you wrong. I'm just trying to tell you guys that when you share, you get to realize that there's a small difference in the way we need to think about. See, sine of A plus B is never sine of A plus sine of B. Agree? This is not the case. Correct? That's why we derive this formula. So, this will not hold water at all. So, what will happen is, so see, I don't have a medical degree, okay? But I'm a math doctor. That's why I'm trying to diagnose where the problem is. Where we are thinking differently, and we will do the course correction together. Okay? There are times when I make mistakes as well, and that is where I seek help from you guys to correct it. This would be my first step. Do you guys agree or you don't? Yeah? And Samriddhi, Sahit, Vishal, and Davik. Okay? I love the way Prince started. Because I'm not here to impress you guys with my mathematical skills. My job is to make sure that you guys think of math like math. Okay? So if anybody is sharing and that answer gets gunned down, there's nothing lost. Actually, it's a gain. Now, since I'm torturing Praneeth so much that Praneeth will never forget this. So use this for your benefit, okay? So Praneeth, I'm not torturing you, okay? I'm just using some wrong examples. Yeah? Praneeth, you okay, right? Yeah, okay. So here, tan of A plus B, see, we know that tangent of anything is equal to sine of that angle by cos of that angle. So A plus B was my angle. Tomorrow if A is 20, B is 70, A is 45, B is 63, doesn't matter, we don't really care. We are not trying to get that absolute value right now. We're trying to convert this into a generic formula for us. Now when we come to this, now we know that okay, sine of A plus B by cos of A plus B. That's what it is. So this is nothing but sine of A plus B divided by cos of A plus B. And since we know this, we already have derived these formulas. We will use that thing. So sine of A plus B is nothing but sine of A cos of B plus cos of A sine of B. This is my numerator. What is my denominator? Cos of A plus B. That we have derived here, which is cos of A times cos of B minus sine of A times sine of B. So while Praneeth's example was an easy one, but we'll probably not go down that path. We will leverage what we have learned by now to get to this, which looks a little complicated to begin with. But are you guys convinced that this is the right approach? Vishal? Vishal, Davik, Sahit, everybody okay? Davik, you're clear, right? I mean, at least when I got you confused with this thing, when I was asking this question, you said I am not sure what to do. But whatever we have done post we discussed, is this making sense to you, Davik and Sahit?
Yeah.
Yeah? Okay. Now we got this. What I will do is, I will do some magic with this. Okay, something like abracadabra. And that abracadabra is nothing but dividing each and every term with cos of A, cos of B. So basically what I am doing is, in the numerator I am doing cos of A times cos of B. In the denominator also I am doing the same thing. Cos of A, cos of B. So basically when I divide this one by cos of A, cos of B, my cos of B will get cancelled out. It will become sine of A divided by cos of A. Okay, first term. Then I have a plus. I am just breaking the bracket open. Okay, so I am dividing this term also with cos of A, cos of B. So cos of A will get cancelled out, and then I will be left with sine of B by cos of B. By cos of B. So this is my numerator right now. Then let's go to the denominator. When I am dividing this thing by cos of A, cos of B, this is 1. And then minus sine of A times sine of B divided by cos of A times cos of B. So sine of A, cos of A will come together. So I will write it this way for the sake of better readability. I know I have used a very horrible font, but I hope given the real state we have here, you guys are able to see what I am doing, right? So basically, if you look at the whole journey, we took sine of 10 of A plus B, and 10 of any angle is equivalent to sine of that angle divided by cos of that angle. And now sine of that angle we know from this formula, we are plugging in this here. Cos of A plus B we know from this formula, we are plugging in here. And then we divided each and every term, so numerator and denominator both, with cos of A, cos of B. That was the magic I was referring to. So when I am dividing this by cos of B gets cancelled out, this term becomes sine of A by cos of A. When I am dividing this term by cos of A, cos of A gets cancelled out, it becomes sine of B by cos of B. When I am dividing this term by cos of B, this is the same thing, so this becomes 1 minus sine of A, sine of B divided by cos of A, cos of B. That's what you have. So sine of A by cos of A, this becomes, if I am coming here, this one becomes 10 of A plus sine of B by cos of B becomes 10 of B divided by 1 minus 10 of A, 10 of B. So we have derived the third formula for angle addition for tangent also. Are you guys convinced or not? Samriddhi's name gets called out because she's the only girl child in this group. So she was the first one to raise this thing. But I'm hoping, I'm assuming that you guys are convinced about what we did, right? We did not do anything fancy. Deriving these two formula was interesting. And then we just applied that formula to get 10 of A plus B, and which is this. And then we divide every term with cos of A, cos of B in the numerator and denominator to get this third formula, which says ten of A plus B equals 10 of A plus 10 of B divided by 1 minus 10 of A, 10 of B. Yeah? So we got three generic formulas. So when you have two angles and you have to find out the sine, cosine or tangent of the sum of the two angles, this is what becomes our way to solve it. Okay? So again, as I always say, that I have a hidden agenda of wasting everybody's time. by proving the formulas, none of you will ever be required to prove a formula during any exam. But then, honestly speaking, math is a subject of concepts, right? If you are not clear about the concept, no matter how many formulas I teach you guys, it will go down the drain. And you will not be convinced, you will not be able to derive. These are the things that you can derive on the fly also, if you are clear about the concepts, how things relate to each other, right? So that's why I stress on proving the formula and then we look at the problems. I hope you guys don't see an issue with that approach, right? Otherwise, I always have a shortcut of giving you guys 10, 20, 50, 100 formulas and say, yeah, let's apply it. But that might not cut ice when we come across a tricky situation where you have to apply some concepts to derive things, okay? So that's why even if I'm wasting your time, please bear with me, because I have certain problems that I am not able to get rid of. One is, I don't get convinced unless I hear a confident yes from you guys. That's why I keep poking each one of you, right? And second thing is, I don't feel comfortable just giving you formulas, say, okay, apply it. Then I'm not doing my job. Yeah? Are you guys okay with that? Okay. Alright. So I'm hoping that sometimes my preaching gets a little boring, but yeah. Keep that aside. Now here, from this one, same way. If tomorrow if I say find out 10 of A minus B, what will that be? I will not do that, okay? I will let you guys think about it or relate to it. Can somebody tell me how will you approach to get 10 of A minus B? What will be your approach towards that? Any initial thought around it? And Praneeth, I am a big fan of you, okay? So don't think that, oh, last time I said something, this old man put me on the spot. No. Whoever exposes the problems are the ones who will get maximum credit for being able to solve things by themselves. David, Praneeth, Sahid, Samriddhi, Vishal, anybody. Tell me, how would you want me to approach this problem? If I have to find out what is the value of 10 of A minus B. Give it a shot. This class is meant for making mistakes.
Can you repeat that?
I'm asking it up. So let's say I know 10 of A plus B. We just figured it out, right? I'm saying now I'm trying to find out what will be my formula for 10 of A minus B. How I can derive that. So can you give me some head start so that I can do the same thing?
We already worked, I know what the formula is because we did it in school. Am I just supposed to say that?
Tell me the formula, then I will see how we can wrap our head around that one. What will be 10 of A minus B?
I think it's like 10 A
Go ahead.
minus 10 B over 1 plus 10 A 10 B.
Okay. Let's see what David says.
It's the same thing.
Same thing. I don't believe you guys, okay? I don't believe you guys till I see it myself. This is the psychological problem that you guys are dealing with. Yep. How can you convince me, guys? I mean, can somebody try convincing me why the formula that you guys gave me, it will be 10 of A minus 10 of B divided by 1 plus 10 A 10 B. That's what you're saying, right? Can you tell me how should I get convinced? Okay, sometimes my questions are not qualified enough. What I'm trying to do is make sure that this formula we all agree to, okay? 10 of A minus B is nothing but 10 of A plus minus b. So this will be, if we go by the formula that we know, it will be 10 of a plus 10 of minus b divided by 1 minus 10 of a times 10 of minus b. And we'll go back to the unit circle to see this is b, this is minus b. So if I'm talking about 10 of b, my x coordinate, I mean sine by cos. So it's sine of b by cos of b. 10 of, when I'm talking about 10 of minus b, I'm talking about sine of minus b divided by cos of minus b. Sine of b by cos of b, this is fine. 10 of minus b is sine of minus b, and we have seen that sine of minus b is same as minus sine of b. My y coordinate flips, y to negative. Cos of b and cos of minus b are the same. So cos of minus b I can replace with cos of b. So this becomes minus sine of b by cos of b, which is minus 10 of b. So same thing, like it worked for sine, 10 of minus b is equal to minus 10 of b. So this will become minus 10 of b. So that's why this is 10 of a minus 10 of b divided by 1 minus 10 of a and into minus 10 of b. So minus into minus becomes plus. So this formula that you guys told me 5 minutes ago, that is correct. And why I was doing all this, what do you call it? I'll not use the word gymnastics, okay? Why I was doing all that was just to make sure that we don't take any formula on its face value. Even if you have used it 100 times, it is worth it to make sure that we are convinced that, okay, this is the reason. Now, these formulas that will come across, let's say, after today's class or after you practice some more problems and when you watch the video, whatever you do, you will not have any doubt in your mind. If somebody says, why 10 of a minus b is this? You can say, okay, I'll show you how and why. Another thing that we found out was, by doing this was that, okay, we have seen by relating this with a unit circle, sine of b and sine of minus b are opposite in sign. So sine of b is equal to minus sine of minus b. Cos of b and cos of minus b are the same. 10 of b and 10 of minus b are same but with a negative sign. So these things you can relate. So tomorrow if you come across a situation where you have to find out, somebody says find out 10 of minus 45 degree. And trust me, when we are in this situation, you'll be able to recall that, okay, 10 of b and 10 of minus b are same but a negative sign. So this is same as minus 10 of 45 degree. And 10 of 45 degree is 1. 1 by 2, 1 by root 2 by 1 by root 2. So minus 1. This becomes a cakewalk without any doubt in anybody's mind. Am I being able to convince whatever I was saying? Yeah? Sahit, you agree with that? Riddhi, Vishal, everybody okay? Yeah, okay. So we have muddled the water enough. Now, in the next class we will go to complex plane. That's the next topic that we are going to pick up. But here, whatever we have learned, let's look at the application of those concepts for solving real problems, right? So far, whatever I was telling you guys is of no use because you will never be required to prove these formulas. But now you will see a different perspective when you come across a problem to solve. Okay? You will have a very methodical approach for solving these problems. Let me try proving that to you guys. Okay. So let's look at some real problems which are not problems anymore. So we have a scary looking problem, okay? 3 pi over 4 cos 5 pi over 12 minus sine of 3 pi over 4 times cos of 5 pi over 12. This is the expression given to us. It says find the exact value of the expression without a calculator. See, now there is a caveat. You have to find out cos of 3 pi over 4 times cos of 5 pi over 12 minus sine of 3 pi over 4 times cos of 5 pi over 12 without using a calculator. And then you are given the options. Option A is root 3 over 2 minus. Option B is root 3 by 2. Option C is minus 1 by 2. Option D is 1 over 2. And I would want you guys to give it a try and tell me how are you going to approach this? Take 30 seconds, let me not bother you guys for next 30 seconds. I want you guys to think about it. I hope you guys can read the question. I'm reading it one last time. Cos of 3 pi over 4 times cos of 5 pi over 12 minus sine of 3 pi over 4 times cos of 5 pi over 12. You have to find out the value of this expression. These are the 4 options that we are given. And this problem you would be able to solve in 30 seconds during the exam if you are very, very clear about it. You'll be actually faster than a calculator if you have learned this concept. A moment of silence from my side. I will do a think. Okay, any clue? I'm ready to hear your story. I don't need answers, I need approach. Anybody? Yes, Manit.
I started by simplifying all of the 3 pi by 4 and 15 pi by 12. And then the 3 pi by 4 would have been a 135. And so what that means that if you have a cos of 135, it will be like the second quadrant, meaning that would be a negative value. And then 5 pi by 12 was 75, so it would have been a positive value. The negative times the positive would have been a negative minus the sine of 135, which would have been a positive value times another positive value. So it would have been negative plus minus another negative, so negative value. So I was able to cross like B and D.
B and D, okay?
Yeah, so it would be A over C.
Okay. Any other thought? Samriddhi, Davik, Vishal, Sahit,
I think it's A.
you think it's A? Can you tell me the approach part of it?
So first of all, it's cos A plus B.
Mm-hmm.
So that would mean it's cos A cos B
Mm-hmm.
minus sine A sine B.
Mm-hmm. Mm-hmm.
And then if I try finding a common denominator between those two fractions, because it's just weird.
Mm-hmm.
So then I got 7 pi over 6.
Okay.
And then I simplified cos 7 pi over 6 to get negative square root of 3 over 2.
Okay. Sahit, Samriddhi, Vishal, any thoughts before I borrow everybody's idea and mark it that as mine? No? Alright. So, see again, I'll go with a combination of what Davik and Pradeep did. Okay? But I'll start with Davik's approach here. Because this is what we have been learning, right? We learned that cos of A plus B equals cos of A, cos of B minus sin of A, sin of B. So this is a classic example of cos of A plus B scenario. So when we talk about cos of A plus B, I'm talking about here my A 3 pi over 4 and this B is my this. So this whole thing will result into cos of 3 pi over 4 plus 5 pi over 12. And then then we said, okay, now we have to add these two. This becomes one angle, cos of some angle. How much is this? Cos of pi is common, we'll take it out. 3 by 4 plus 5 over 12. So we said, okay, fine, to make a common denominator, I'll multiply by 3, multiply by 3 here also. So this became cos of pi times, this is 12 denominator, 3 into 3 is 9 plus 5. I hope I'm not making any mistake. 4 3 is 12, 3 3 is 9, 9 plus 5, 14. Yeah. So this became cos of 14 by 12 pi. Now this can be as good as cos of pi plus 2 pi over 12, right? So 12 plus 2, right? So 12 by 12 becomes 1. So pi plus 2 pi over 12. That is 6. So we are essentially talking about cos of pi plus pi over 6. Now you go to this unit circle. Pi is here up to here and plus pi over 6, that is 30 degree. So cos of 30 degree is what you are talking about after pi. So here your x coordinate will be cos of 30 degree but with a negative value. And cos of 30 is root 3 by 2 with a negative value. That is why this one. So your idea, Pradeep, you were trying to find out, okay, this one is positive, one is negative, one is positive, one is negative, and then from that you try to rule out the two. But since you started with finding individual value of these ones, we could not leverage this formula that we had at our hand, right? That's why you could not nail it down to one option. If you would have started with this part and would have landed here, after seeing the unit circle, you would have said, okay, fine, my value is negative. So this one is ruled out. I'm leaning on one of these two. But pi plus pi over 60. So we are talking about this angle here to here. And then you're landing in this situation where your cos of pi plus pi over 16 is, you're talking about this triangle's magnitude and then relate that unit circle and say, okay, fine, my x coordinate is negative. So that's how you got to this point, right? Yes, Praneeth.
Cos A plus B, wouldn't it be cos A times cos B minus sin A times sin?
Did I write the question incorrectly? Let me read the question one more time. You are putting me on the spot. Yes, you are actually right. So, Davik read my mind, not the board. Okay? So, when you have cos of A, cos of B, I mean, this is the formula that holds true. So, again, you were not wrong with your approach, but if this question was written correctly, then you would have probably tweaked your approach. David probably either could not read this part or he assumed that I have not made a mistake. Yeah. But yeah, this was leading towards relating this equation with one formula, and then from that you simplify it, create the unit circle, rule out the options. So you don't have to find out the value for these guys individually. Even if you have a calculator, when you try breaking it down and then try doing it, it will take longer than relating that to the formula and then deriving it. Okay. I hope Vishal, Samriddhi, Sahit, you guys are with me as well. Vishal, Sahit, everybody okay? Yeah. Now let's look at one more problem. Okay. And again, this is like a playground. Okay. Interestingly, with you guys, there's a 49-year-old man who is playing. Okay. Just allow me to be part of a team. We are playing a game called math or a game called pre-calculus, and whatever we know, we are just applying those concepts to deal with them. Again, let's do it playfully. So this question is, it says find sine of 13 by 12 pi. Exactly using the angle addition or subtraction formula. It is giving you the clue also. Using an angle addition or subtraction formula. And the options we have are root 2 minus root 6 by 4. This time I promise I will make sure that I don't write the question incorrectly. Just to make sure that I don't compromise on my self-respect. Huh? No, I don't really care much about my self-respect part as long as we are having fun with math. Okay. So the other four options we have. We have an expression sine of 13 over 12 pi, and says find the value of this using an angle addition or subtraction formula. And the other four options we have. How do you guys approach this one? Tell me the approach part of it. Take 20 seconds to think about it. Then I'll start bugging you guys. We are approaching end of the class, so let's see. How would you guys approach this one? Anybody? Vishal, Sahit, anybody? I want everybody to participate with me, okay? Make me feel younger when you guys participate with me, okay? I have no plan to color my hair black, but I want to engage with you guys. Yes, Vishal, go ahead.
I haven't figured out the answer, but if I were to approach it, I would first simplify it to 3 pi by 12 plus 10 pi by 12. And later I can use the sine A plus B formula and substituting it in there.
How about this?
Yeah.
So this becomes sine 1 plus 1 over 12 pi. Or I can say sine of pi plus pi over 12. Is that okay? Yeah? So pi over 12. Now see that. And this is where this horrendous drawing of mine could be of some use. Pi over 12. Pi is 180. Over 12 is 15. right? Pi over 12 is 15 degree. So we are essentially talking about pi, which is 180 plus 15. This 15 degree. Yeah. So essentially we are talking about 180 plus 15, 195 degree. Now, what you would want to do is basically this pi, so you're trying to find out the value of sine 15 degree from this one, okay? And use a negative of that. That's what we'll do. So from this one, you'll say, okay, fine, this is equals sine of a plus b, sine of pi plus pi over 12. So sine of pi times cos of 15 plus cos of pi times sine of 15. And we'll have to find out the value of sine 15 degree, right? Again, applying sine of 45 minus 30, that will give you 15. Similarly, you will find out cos of 15 value also. Now here, what is the value of sine of pi? When you talk about sine of pi, your y value comes to the x-axis, which is 0. So sine of pi is 0. The y coordinate value is 0, right? But when you are coming to this point, yeah? Similarly, what is the value of cos of pi? Cos of pi is actually 1. So this is 1. Then you don't have to find out the value of this guy. You have to only find out the value of this guy. And cos of pi is 1 times sine of 15 degree. So you have to find out sine of 15 degree now. That will be equal to this value. Am I making sense or no? Yeah. So now sine of 15 is nothing but, then you are saying okay, sine of 15 degree is 45 degree minus 30 degree. So in this one problem, you are applying the sine angle addition formula and then angle subtraction formula both. Yeah. And trust me, when I started this question, I had no clue. Okay, I don't practice questions. Before the class, I look at the concepts and then I assume that okay, whatever practice I have done, that in my childhood days, that should be enough for me to take it forward. That's where at times I go wrong also. I take a little longer also. So here, when I start breaking, see this is a what do you call improper fraction, right? So this will convert into one natural number plus a fraction. So that is how we got this. So this gives us a clue. Okay, what angle we are talking about? Oh, this is 1 by 12 is 15 degree. Okay, fine. And then we relate it, right? So net for any problem like this, as long as you know how you're going to break it down, how you'll approach, all the scribbling that I'm doing right now, this is exactly what has to be part of your life as well, for being able to solve these problems without going wrong. If you don't do this scribbling, you will probably end up struggling a little bit more. Because when you get started, right, that's why I keep pushing you guys to do some scratch work. When you do scratch work, this starts opening up the path for us to be able to solve it. Yeah. I had no plan of doing any preaching, but I hope I am making sense to you all. Okay. Sahit got dropped off. He got tired of me. All right. So yeah, you guys don't have a choice of being tired of me, because I don't get tired when I'm teaching math to you guys. All right, have fun. We'll talk again, and request you guys to do some unit test in Khan Academy and let me know where you guys are struggling so that we can break our heads together. Yeah. All right. Bye bye. Good night. Bye, Vishal.